There it is.
Everyone can see it?
Yeah, looks great.
Okay, let's get started. Hello, everyone. I wish when you see this title slide with AI stuff, you don't freak out and you want to nod off or go out and filling your empty stomach right away, because I know it is lunchtime now actually, but just hang on some minutes. Who knows, I might interest you with a whole new research direction in the near future. And so I am Binh D. Lê, a PhD candidate working under the supervision of Professor Inu Park. And on behalf of our research team today, I'm really honored to be here to talk about our latest project using AI model to predict composition of kidney stones. And suppose you had a kidney stone and luckily it would pass out without leaving you in a terrible pain. If you went to see a doctor based on its compositions, the doctor could tell you why you had it and how you could prevent its recurrence. But to determine its compositions, the stone often be sent to a commercial laboratory. But that kind of lab is not available at many places in the world. And thanks to technological developments recently, we believe that AI could be really an alternative solution for that problem. So before start, let's do a literature review. So far, researchers have tried different AI models to tackle the issues. And here I'm going to lay out the two noteworthy studies. The first one, authors designed a very specific device. With this one is a digital camera trying to taking a picture of a stone outside here. And the authors using random forest classifier to predict the stone composition based on its colors and texture. And their model achieved a quite impressive overall accuracy of 63%. In the second paper, authors using a pretty small sample size of only 63 pure stones contain only single substance for one stone, and they generated 126 images and using ResNet 101 algorithm to predict stone composition. And even though with the small sample size, the performance of the model is quite really impressive, with accuracy of 85% and sensitivity as well as specificity or approximately 90%. So our study was carried out with a different algorithm, the CNN, which stands for convolutional neural network. After collecting 300 stones and generated 600 digital images of those stones, we simultaneously sent those stones to a commercial lab using a standard method to detect its actual composition. For the 600 digital images, we use it for training our AI model. And by combination of the prediction of the model and the actual composition of the stone, we take it into the evaluation of this model. But how exactly CNN works? Let's take a closer look at it. So say we had a picture. We all know that the picture is comprised of pixels, and each pixel has a value. So basically, a picture contains many numbers, and a CNN model will use a filter like this pink square here. Note that the left column of the filter has a value larger than the middle, and the middle has a value larger than the right. By applying this filter to the whole images, we multiply each corresponding position of the filter to the corresponding of the images, and we do summation of them all. We have the output, and we have the number in the output here. And then we apply the filter over and over to the whole images. We have the output, and you can see that in the right column of the output, the value is larger than the middle, and the middle is larger than the right. So if we apply this kind of filter, we can detect the vertical line of the images. So let's say we are trying to detect the number of the handwriting figure. So by applying many different type of filters, we can detect the lines of the figure. Let's say we trying to detect the number 7, and you know that the number 7 is contains of a horizontal line and an oblique line. And if we apply the filter with appropriate figures, we can detect like this one, the oblique line, and then somehow we can have a horizontal line, and the model will say it is actually the number 7 with about 100% of confidence. It's really impressive, isn't it?
Yeah.
So we're using the same principle, and our model achieve a really promising result. In the training data set, the accuracy is about 80%, and the area under the curve about 0.996. For the testing data sets, which contain the unseen images, the model haven't sent those images before. The result drops a little bit for about accuracy of 85%, and the AUC is 0.98. Nonetheless, our findings suggest, though it looks very promising, but our data were pure stones, which just contain only single substance. But in real world, stone could be comprised of 2 or more substances. Nonetheless, our findings suggest that AI could really be an alternative solution if traditional methods are unavailable at that time. And before ending my talk here, I very appreciate your attention. Of course, there are so many things I must skip to fit the time frame. So if you'd like to know more about our work, please feel free to contact me at the email address. Thank you.
All right. Great work there. Just like you mentioned, you were going to cut out a lot of the really technical stuff. Totally fine to do that. This brings us to about a little under 10 minutes. So
yeah.
Did you plan for that? Did you kind of time yourself before one time?
Yeah, because I know it's a lunch time.
So sometimes when people say that, it's an empty promise or it's kind of an empty concern, but you truly meant it. You're like, I'm going to make this short and sweet, everyone. Like, I'll break it down for you and then we'll go pig out. We'll go have some lunch, right? So it's not an empty concern that you have for your audience. That's kind of nice. So yeah, in terms of time, it was about 8 to 10 minutes. Structure, let's see. Just like Mushtaq mentioned, you used numbers on your slides, which is great, right? Something I should have mentioned before earlier in the program. It's a really good idea. I'll add that the next time I teach this. That makes it really easy to find previous points, but also any errors if you need to, or if someone has a specific question, they can point straight to slide number 5 or 4 or whatever. So that's excellent. Very good intro because it was a nice touch. You engaged with the audience by mentioning 2 major things, right? The time, which corresponds with possible hunger of the audience, and also the difficulty of the material, right? So don't snooze on me, don't fall asleep. We'll get done with this quickly and then we'll go enjoy our lunches. So nice little touch. You didn't have to do that. And in the technical science-based fields, you know, it's totally not necessary, but it's a nice touch, right? It does humanize the otherwise difficult material you have. Let's see, your transitions are very good. Just like with Mushtaq, you know when to stop and then when to switch and then when to start, right? You're very good at stopping and starting. And your message didn't bleed between slides very much. It was clear when one was finished and when the other was starting. Great transition there. And the overall structure, I mean, everything was there pretty much. Introduction with agenda, transitions, methodology, etc. And it's really great that you talked about other major articles that had been published in your field. It shows that one, you know them well, but two, there's a problem. There aren't too many. And so your work is important because you're adding to that very limited knowledge base or kind of body of data. In terms of voice, clear projection, you seem very comfortable talking about this. You have a pretty laid back voice. I don't know, has anyone ever told you this? You sound really chill. I don't know if anyone's mentioned it, but it does
No.
always, it just sounds like you're kind of hanging out in a cafe together. This is great for sounding more personal and just more like a real human talking to another human. If the microphone system's not good where you are, though, this could be a little bit of an issue. You might have to project more because you speak fairly clearly, but it's just you do sound really like you're using like an inside voice, like indoors voice. And so in front of an audience, you might have to project a little more, but that depends on the venue, how big the room is, how good the sound system is. So just keep that in mind. Your voice is naturally pretty chill. You might have to kind of crank it up a little bit though. Let's see. Pace, your speed is excellent. It's really good because you could easily lose someone with this technical information, but it's hard to get lost when you have a pace like yours. It's not too slow, which can be annoying also, but it's really just like medium. It's such a good pace for this material. That's why you sound so relaxed. You also, like Mushtaq, you sound very comfortable with this material. And so you're not rushing anywhere and you're not getting kind of tripped up on certain words. You seem very much in control of what you're saying and very familiar with it. So that's great. Pace is fantastic. Very few ums. I think I'll say way more ums in the next two sentences than you did for the whole presentation. No ums, I think, or very few. What else? Visuals. This part, yeah. Slide 4. Could you go back to slide 4? Yeah, on the bottom right and also in the center, these ones are quite hard to see if the point is to see the words. If your point is to read what's there, it's really tough to see that. They're a bit blurry. However, if the goal is to just see the general picture or the image of the stones and the general trajectory of the data on your graph there, then it's not as important. I would recommend trying to find higher resolution images and to expand them, to pull them out a little bit, make them a bit bigger. You do have a lot of white space on this screen to play with. And so that gives you a little more room to expand your images. Again, it's mainly if reading is also important, but generally, yeah, I would say just try to expand those a little bit more. As long as you can get clearer images though. If that's the clearest image you can get, don't expand them. All right, keep them there as they are because it's not going to help. All right, let's see. Yeah, I think the CNN model, the graphics, I think that's a new addition, right? We didn't see that before. That's really cool. Like it looks awesome. And it really shows you how the system works to identify digits and also letters. It was cool. I thought that was awesome. It simplified things. If you had to just explain that without any image, I would have just zoned out. My brain would have gone to somewhere else. But because of the imaging there, it was really easy to follow. So great addition, really, really cool detail. I loved it. And slide 7. Let's go to slide 7. Yeah, okay. This is the smallest nitpick ever. It's almost useless. On the right side, accuracy, 85%. Just need a colon there. Just
Sorry.
dot, dot. That's
Oh
it.
yeah.
It's so stupid. Don't stress out about that. It's just to keep things consistent. But other than that, I didn't notice anything that needed to be changed with the PPT. So awesome. Well done. Just add a colon, save it, and it looks great. So general language usage, nothing, there wasn't anything that really jumped out. There was just one word, used, in the past tense. We did talk about final ED sounds. I don't remember if you were there. I think you missed that part. That's right. That's right. You had a meeting with your professor at that time. We talked about final D, ED, IED sounds for verbs in past tense and also for adjectives. And here for used in the past tense, I just heard use it. And that id is not the correct final sound. It can be a d, a t, or an id for these final sounds. And it happens to just be used, it's just a D. Tiny, tiny, tiny thing. But we did talk about it specifically for about 20 minutes in class. So that's why I mention it. It's in the materials, so you can at least review that part. But the problem is there's a recorded aspect to it that we can't recreate. It's gone forever. But anyway, that's it. So again, this is another example of presentation that would get a very high score. So well done. All right, cool. Do you have any general comments or questions for me or about the presentation in general?
Because I added the CNN model part because I know this is actually the project I made up. I haven't have a result yet. So I know that the result is I made it up. It's just one slide. I have nothing to talk about. So
okay.
Basically the CNN model is the key part of my presentation here to help you to know what I'm doing here.
Okay, so it's something you hope to use for your research later, I guess.
Yeah, I'm actually using it, but I haven't have the result to show here.
Okay, got it. Well, that's the hard part. Some of us are in different stages of our research here in this class. Like Yunha's done, right? Yunha's totally done with hers. And Mustak, I don't know if it sounds like he's done, but there's still one or two things he's working on. Unbil has told me before that she's very early on in her process. And in your case, it sounds like you're still early or midway through as well. So, don't stress out too much about that. I'm not grading people based on how finished they are with their research. So don't stress out there. But it was a good addition. It fooled me. I just thought, wow, this is cool, So distracted me long enough. Okay, cool. So we'll stop with the recording there. And I guess I'll say